Working? Hi. Good morning, everybody. Hope you're all doing well and you're nice and refreshed. This is my first presentation at a mum, so hope everything goes smoothly. Well, aside from laptop-related setup issues. So this presentation is called "This is why I hate MikroTik." Certainly have received some interesting comments about the subject prior to doing the presentation. So let's see how this goes and how we're doing. Just a little bit about myself. My name's David Savage, and yes, that is my real name. Get asked that question a lot. And no, I'm not a part of MikroTik Latvia in any way. So MikroTikSA is a completely independent company. We are from South Africa. I'm a certified trainer and MikroTik support engineer. Been doing this for quite a while. I delivered my first training session, which was on the Moodle platform, somewhere around 2004. So at that stage, the current rank of MikroTik certified trainer didn't exist. I just ran through a training program with the guys from MikroTik, and after that they said, well, you can now go out and train people. So through the years, I've used MikroTik a lot. Definitely my platform of choice for just about anything. I think I have one linked up to my coffee machine. Makes very good router-based coffee. And throughout the years, I've been through a fair amount of conferences, been to other mums and so on, and there's a few threads of conversation that pop up again and again and again. So it's generally people complaining about MikroTik and things that MikroTik can't do or things that MikroTik doesn't do very well. And this is an attempt to try to outline just a few of those, but also to make a point that very often it's not MikroTik itself that's the problem, it's the lack of understanding about what they're trying to do that is causing the issue. So I'm from Cape Town. I did mention South Africa, and a little picture of what Cape Town looks like. Well, just realizing it's not great quality, but really it's a very nice place. Okay, so full disclosure, I actually do love MikroTik. Don't read anything into that title. So what is this presentation about? First of all, I'm going to outline 4 things. Common misconceptions. So what do people think MikroTik can do versus what it is capable of? Unrealistic expectations. People expecting the router to be able to do something at a certain speed or a certain level of performance and not understanding why it can't do that. Lack of research. Of course, this ties back into unrealistic expectations. If you don't know what the hardware platform is, then you're not going to be able to leverage it correctly in terms of getting the best out of it. And thirdly, lack of understanding. So again, tying into the 3 points beforehand, not understanding what the product is about and what it's meant to do. So it all comes down to the statement right at the bottom. Person says, I love MikroTik, but why can't it do this one very specific function that will make it absolutely perfect for me in my network? And I think that's fair enough. And I think it is because MikroTik is such a capable routing and switching platform, and it has so many features that people are almost surprised when there's something that it can't do, something very specific to their needs and requirements. There was a great example of this yesterday, and I hope the gentleman that I was sitting with on the tram is in the audience right now. There he is. I saw him wave his hand. How are you doing? And I was riding on the tram with him and telling him about this. And he goes, oh, I love MikroTik, got lots of them in the company, but why can't it do, I think it was radius-based per port MAC address authentication in his network, because he wanted to be able to block certain MAC addresses by radius. And I'd never thought about it before, so it's not something that I've ever had a need for, but that would almost perfectly illustrate what this is about. So it can do everything inside the network, but it cannot do that very one specific function that would make it absolutely perfect for his needs. So I thought about it a bit and came up with some possible other ideas, like perhaps it can't do that exact function, but maybe you can work it around it in this way. Perhaps you could use DHCP-based radius authentication, use that to create a MAC address list based on the DHCP lease and try to block the ports in that way. And I think that illustrates it yet again. So perhaps MikroTik can't perform the exact function that you want, but very often there's a workaround. It's extensible enough to be able to create the necessary scripts or hand off to some other device that may be able to do the job for you. It does allow for that extensibility and that expandability. This is an actual conversation from a technical conference. It was a couple of years back. It was probably 3 to 4 months before RouterOS was released on the MikroTik platform. So it's a big IT tech support consultant from a very big telecoms provider in South Africa. And the first thing he said to me after figuring out who I was, why doesn't MikroTik support RouterOS? I'm deploying thousands of CPE devices on our FTTX network, and this would make my life so much easier. And I said, well, I have seen rumors about it on the request list. So have a look around. Perhaps it will be there in a few months' time. And of course, he went off mumbling and groaning about this. Fast forward around 6 months, I saw the same guy, different conference this time. And the first thing I said to him was, hey, check it out. MikroTik now supports RouterOS. And his response back to me was, well, I wish they would stop wasting time on small things like that and bring out RouterOS version 7 already. Okay, so that is typical of the kinds of conversation that I'm having with other consultants in the field. So let's then look at some common misconceptions. I'm going to start here with outdoor wireless because this is something that I deal with quite a lot. As an aside from being a MikroTik trainer, I also run a moderately sized ISP or a service provider in Cape Town, and we use both wireless and fiber quite extensively in our network. So I have experience with many, many different products from many, many different vendors, but time and time again, we try something else out, and we tend to end up coming back to MikroTik in the end. So that's the typical kind of complaint that I get. Well, product A, B, C, Cambium, Mimosa, Ubiquity, whatever, they're so much better than MikroTik. Just plug it in and it works. Yes, that is true to some extent. Yeah, MikroTik doesn't have a set up everything at once button that just figures it all out for you. However, if MikroTik does have the more complex setup where it does take longer to set up and fine-tune a link, but it does give you very, very fine-grained control over every single aspect of your wireless interface. Whereas with the other devices, if the one-button setup doesn't work for you, then that's it. You're stuck with the setup that you have. There's not much space to experiment around with the settings and try something different now to fine-tune and maybe tweak that particular link to get exactly what you want in from it. So rather than dumbing things down and going, well, we'll just give you this single-click button that does everything for you, MikroTik gives you absolute control over every single aspect of the wireless interface. However, fair warning here, you do need to know what you're doing. Yeah, if you don't know how to set the device up properly, you're not going to get the results that you want or need. Another thing I want to highlight, and this again is from working with many, many different products, is there is no magic bullet solution. There's no one product that can service every single component of your network. So various wireless manufacturers have various types of technology, goes under many different names. I've heard about AirMax, WJet, iPole, Canopy, Jet, and so on. Ultimately, though, it all comes down to the same thing. It's really just TDMA protocol that they've modified or massaged in some way. So if you're not aware of it, MikroTik has its own version of TDMA, time division duplex multiplexing, and it's called NV2 or N-Stream version 2. So if we just want to call it N-Stream version 1 was a polling-based system, which is technology sort of similar to Token Ring on Ethernet, where it would poll various devices and ask them if they needed to send data. So that solved various media access problems that you have with the standard 802.11 protocol. Yeah, problems with links over long distances, problems with hidden node clients, i.e. where two clients cannot see each other's wireless signals directly, solved all of that. So they built on that with leveraging TDMA in the NV2 system in order to improve that in all aspects. So even better handling of multiple clients, better handling over distance, and so on. And as I said, every single other product is just based around the same thing. If you really drill down to the specifics of what those devices are doing, they're just using some version of TDMA that they've tweaked, massaged in their own way in order to deliver their product. So yes, perhaps they have antennas with some fancy beamforming technology, and that can work very well. I mean, there's nothing wrong with beamforming. It can be very, very effective in terms of focusing signals to clients. Perhaps a bit more in terms of fancy antenna elements and so on, maybe slightly fancier software. But ultimately, if you're comparing the same technology with the same technology, I believe they are similar enough to each other so as not to make that much of a difference. Yeah, maybe a few percentage increases in performance here and there. When it comes down to wireless, though, if you're dealing with wireless a lot, especially as we have in Cape Town, we have sites with huge numbers of wireless devices. We can do a scan from one of our high sites and pick up anywhere from 400 to 500 SSIDs all at the same time. So that's the kind of noise levels that you're dealing with. And you can't change physics. Once you are out of spectrum, you're out of spectrum. There's no amount of magical beamforming isolation technology that's going to get around that. If the entire 5 gigahertz band is used up, then it's used up. Yeah, and aside from moving to a different frequency, there's nothing you can really do there. Almost any amount of fancy technology is not going to do the trick. So what are you going to do? Probably going to use a giant-sized, 1.2 meter antenna with a ultra high-powered device that's just going to try to drown everything else out. But that's going to work right up until the time your competitor puts exactly the same thing on his tower, pointing right through your one. So you're going to be back where you started. And on the other side of that, any wireless device will perform well under perfect network conditions. So it's great seeing product X with a 500 megabits per second AC throughput, but that would be in an environment where there's no other noise, and you can get that kind of performance because there's nothing else to interfere. And the other common one is customer X will go, well, I replaced my MikroTik with a, whatever, Cambium, and, I went from 10 megabits per second on that link to 100 megabits per second on the link. I go, well, that's great, but what did you replace? What was there before? And so it was this old rusted grid with a CM9 antenna and a router board 133 that I think I might have put in there 10 years ago or so. Well, of course it's going to be different. You had taken that system and replaced it with, let's say, a new net metal AC with a nice new MAN 30 precision alignment antenna, you're going to get exactly the same level of improvement. Of course, it's going to be at 1/3 of the cost, and I'm very, very happy with that. I'll be very happy with a solution like that. So yes, replacing old equipment with new equipment, you're going to get an improvement. There's absolutely no doubt about that. And I think it would be very unfair to say that manufacturer X is now so much better just because you use equipment that was 10 years newer, and in those terms having better modulation techniques, AC, whatever it might be. Just a few things you may not know, a couple of things that makes the NV2 protocol unique. Yeah, I said all the manufacturers use TDMA with their own little software tweaks, so MikroTik has their own little software tweaks as well. And it does have some very, very powerful features that can optimize your bandwidth distribution and also allow you to sync access points together. So the first thing just to mention is something called Uplink Percentage. So by using Uplink Percentage, what you can do is, what the system will do is it will prioritize the NV2 time slots to favor either upload or download as is per your requirement. So you can see a little screenshot I have of just circled in red there where I've enabled fixed downlink and set my downlink ratio to 80. So what this will do is instead of running the system at roughly 50-50 in terms of upload and download time slots, it will now start prioritizing the downlink slots, push 80% of the traffic towards the downlink slots and only 20% towards the uplink. So if you had a connection running at, say, 50 meg down and 50 meg up before, that might now change to 80 meg down and 20 meg up as a comparison. So prioritizes, sends more time slots to one of the directions. This is great in quite a few applications. So for a lot of internet service providers, generally the download percentage is going to be much higher than the upload. So you'll tend to use probably 70 to 80% of your bandwidth on download to clients, and far smaller percentage on their client upload. So by using this, you can leverage the higher percentage download in order to deliver better service to your clients in terms of what they need on the download side. If we look at the other side of it, something like a CCTV camera system, there we're looking at the opposite thing. So you're not downloading to the camera is from the site uploading to your DVR. So by switching that whole thing around, assigning more time slots to the upload portion of it, you can optimize your CCTV system to allow you to make better use of your link and not waste unnecessary time slots on the download section of it, which is really hardly going to be used. Another feature of NV2, and this is also fairly new, is the master-slave configuration. So this is something that is prevalent across quite a number of different products. However, most of them use some kind of GPS sync in order to sync the time slots. Well, not really sync the time slots, sync the devices in terms of sending and receiving. So the system from Ubiquiti, what it does, it makes sure that all APs are transmitting at the same time, and the same goes for clients. All clients transmit at the same time. So it makes sure that you don't have a situation where one AP is transmitting while the other AP or client is replying back to that same site. MikroTik did it slightly differently. So what the NV2 master slave does is it syncs the NV2 time slots across all APs at the same time. So it means that the time slots are shared between multiple APs on a site, which gives you a couple of interesting options. So for example, you can use the same frequency on multiple access points at the same time on the same site, because none of those access points are going to be sending information at the same time. So by syncing together all your APs that run on the same frequency, you can have much better utilization of, let's face it, very, very scarce spectrum that you might have on your site. No GPS sync module is required, which is not the case with just about every other product out there. So that's bonus point number one. And the other great thing, which is again unique to MikroTik, is it's backwards compatible against every other MikroTik product. So it doesn't matter that your device doesn't support 82.11n or AC or whatever it is, you can roll this out in your network straight away. Again, with every other product I've worked with, this will only be supported on their latest product. So you must have latest AC maximum product in order to run the new technology. MikroTik likes making things backwards compatible across every platform out there. So there's an example of setting up sync where I've set this up as a sync master. You can still set the download ratio, can work along with the syncing system. And you just need to specify the same sync secret across devices that you want to sync together. So by having different sync secrets, you can have different devices that are running on the same frequency just syncing to each other. Again, still sticking with wireless, just going to the indoor wireless side. Same complaint again. Well, product A, B, C, and so on is so much better because you just plug it in and it works. And it has such a cool management system. Look at this fancy web interface, has lots of fancy pictures on it and lights blinking on and off. However, very often, when you really drill down into that web management interface, it doesn't give you that much back. It looks great. It's good for impressing clients. Look how expertly we are managing your system. But in terms of real, usable, useful information, tends to be rather limiting. MikroTik, on the other hand, have given us CapsMan. Doesn't look like anything. I'll show you a quick preview. So that's CapsMan in all its glory. But it is by far one of the most powerful wireless management systems that I've seen. It gives you absolute fine-grained control over every single aspect of your access point. And I know Ron will agree with me. He's out there. Ron, you here? Oh, somewhere around. But yeah, if you've ever seen Ron's presentations on CapsMan, then that'll give you a taste of just how powerful it can be and how effective it is. Oh, there he is. How you doing? How effective it is as a wireless device management platform. Just a quick rundown of the CapsMan features. Again, doesn't require dedicated hardware. You don't have to run it on your laptop or whatever it is. How many of you have had somebody set up Ubiquiti's Unify on their laptop and then leave the site, and after that, you can never ever manage those devices again? Yeah, I'm seeing a few nods around, so you're not going to have this problem yet. Yeah. Any device run in RouterOS, provided it has a decent amount of memory and a bit of processing power, can run CapsMan. So just install the package, enable it, and you have a CapsMan system ready to go. Supports unlimited caps or access points, 32 radios per cap device, along with 32 virtual interfaces per master radio interface. Okay. Having just last week in Cape Town set up a system for a client where they had 380 Ubiquiti access points, and every single AP needed a different SSID tied back to a VLAN. There's a limitation of 4 SSIDs per unified device, and that became a real pain to set up, I can tell you. So at that point, I really wished they had gone with a MikroTik platform. Would have made everyone's life, especially mine, so much easier. Can connect via MAC. There is no need to have an IP address on the cap device whatsoever. If your cap device is directly connected on layer 2 with your CapsMan server, you have an instant setup where you have to do just about nothing. Make sure CapsMan is set up, make sure the cap is ready to be adopted, and that's it. Once they start up, it'll connect to the CapsMan automatically, set itself up, and be good to go. It also has IP layer connection features. So again, if the cap is not directly connected to CapsMan, a little bit of extra configuration is required. You have to tell it where the CapsMan server is, but once you've done that again, it can be set up and run in that way. And it can run as a central system where all the data moves through the CapsMan and then out onto the network, or the CapsMan can just manage it from a setup point of view. So the cap can have an independent internet connection or network connection and not have to be directly connected to the cap in order to move traffic through in that way. Next thing then is unrealistic expectations. So we're looking at hardware specification, software specification, and reasonable application. So in terms of hardware specification, this is probably the most common issue that I come across, and I'm fairly sure a lot of you guys as well. Why is my router slow? Why is this router not performing in the way that I expect it to? And it's really about clients not checking what it is that they're purchasing. So if you're purchasing a HAP Lite, what does it cost? $20, somewhere around there. They're talking about a single core CPU, 650 megahertz, 32 megs of RAM, little 16 meg flash in it. Has anybody got an idea why that couldn't run as a PPPoE server with 200 connected clients? When it would be insane. You would think that, however, my clients seemingly don't agree. They would absolutely try to use the cheapest device they could right at the edge of their network to run all of their network traffic, and then wonder why it is that a $20 device can't run the entire bandwidth for their whole network. So you need to understand your hardware. Check the specification. Does the hardware suit my application? Is this built for what I want it to do? Is this a small office, home office router? If that's the case, don't expect it to work in a corporate environment with high-end bandwidth and a high requirement for lots of processing. Could this be handled better on the CHR platform as opposed to using a ready-to-go MikroTik router? And of course, this would tie into the previous presentation that we had. Kevin just went through quite a lot of detail around where you might want to use a CHR versus using the CCR or something similar as your routing platform. So unfortunately, this is just a bit of a repeat of what has gone on in the previous presentation. But if you're looking at CHR versus CCR, first of all, CCR is a Tilera-based, many CPU cores running at a relatively low clock speed, versus the CHR, which cloud-hosted router, of course, being an x86-based, usually much lower CPU count, but at a much higher speed per CPU. So you want to leverage your usage of the device, okay, based on what it was built to do. So what are the benefits of using the CCR? First of all, it's got an excellent price versus performance ratio. You know, for the type of device it is, with the number of ports that you can get, with the number of CPUs, really there's not much that compares to it in terms of price versus performance ratio. And the CCR is designed, or it's optimal, when you need lots and lots of small loads balanced against many CPUs in multi-thread capable situations. Examples of that is many parent or child queues in quality of service systems. So you want to balance the flows of a whole lot of different types of traffic at the same time. Another example might be multiple PPPoE accounts with many queues, or queues per account in a system like that. And this is an application where I've seen the CCR quite commonly used and where it does perform really, really well. So we have the option there also on the CCR, multiple ports, either at 1 or 10 gigabits per second. So we can leverage multiple connections at the same time, and also low power consumption. So just took an example. I've put the link up there. Can go watch it. It is quite interesting. But this is an example of 30,000 PPPoE connections on a CCR 1072. So if you can see the CPU load there, it's run an average of 29%. There's excellent performance when you are talking about lots and lots of small connections in that sense. CHR, or bare metal, what I mean by bare metal is you just install RouterOS directly on the device itself, so no other operating system, just installing ROS from scratch. You're talking about high speed performance on a single thread. So this is excellent for applications that either can't or won't use multiple cores effectively. Examples are given: BGP convergence, that's a classic one. You're trying to converge two full routing tables, 1.2 or 1.4 million routes or something like that. Everything's going to try to run on a single core. Also, firewall intrusion detection systems. Again, the firewall only leverages a single CPU at a time. So if you have trying to handle many hundreds of thousands or millions of new connections through the connection tracking table, that is really going to stress out that particular CPU in a large way. And combined with layer 7 filtering, where you have to have a lot of processing on several packets at a time. So if you didn't know, layer 7 can't process something on the first packet. It usually needs at least 10 packets in order to start the processing of the layer 7 filter. Again, requires high single thread performance. The other thing about bare metal is it's usually costly. Server platforms are not cheap, so you're looking at several $1,000s in order to have something like that, and very high power consumption. So if it's inside a data center, that's usually not a problem. If it's out on a remote site where you might be using solar power or something similar, then you're probably not going to be able to use a platform like this, because you just can't spare 500 watts of power to run a x86 platform. So again, thanks to Kevin for his presentation from last year, which is the CHR as a BGP edge router. And he demonstrated there that BGP convergence of two routing tables over 500,000 routes on Hyper-V took less than 1 minute on the, I think it was the Baltic Vengeance CHR. CCR, on the other hand, could take anywhere up to 10 minutes to do the same thing. Okay, it's a ridiculously long time. And the reason is, again, it's going to only leverage a single CPU in order to try to do that. So for that application, it's all about the CPU speed that you have. The higher the speed of the CPU, the better it's going to work. Even, for example, the root port for 4011 converges BGP a lot faster. So I've seen tests on a single root table, full route table, about 600,000 routes or so, and I think the CCR took about 1 minute 40 seconds to do it, and I think the 4011 was done in around 45 seconds, so something like half the time on a 4011. Okay, and again, just coming down to the performance of the CPU itself. The next thing then is lack of research, and this ties into the other 2 points that I made. So client says we're running IPsec on our network, we've installed this MikroTik router, might be a fairly expensive router as well, and it has slow IPsec performance. So first of all is, does the router support IPsec hardware acceleration? And if it does, are you using authentication and encryption protocols that are accelerated on that device? There. So I've put the link up there where it shows every single MikroTik router and whether or not it supports IPsec hardware acceleration and what types of authentication and encryption it does support in terms of that. So you need to match your hardware along with what you're trying to do with it. Okay. If it doesn't support IPsec in hardware, it's going to have to do it in software, and it's going to be very, very slow. There's no doubt about that. A great example of this was the router board 3011, which for a very long time didn't support hardware acceleration. I know in the later versions of RouterOS that has been sorted out, so now the 3011 does have hardware-based IPsec as well, but that was a fairly large problem prior to that. Next common one, my router has slow bridging or routing performance. Again, this ties into Jono's presentation from yesterday. You need to understand what the hardware architecture is and how that ties together with what it is that you're trying to do. So have you researched the board architecture? Which ports are connected to which switch chip? Yeah, if you're using it for routing, how many paths to the CPU are there, and which ports are connected to which path to the CPU? Are you using hardware offload where it's available? If you are using the hardware offload, is the hardware offload on that particular device compatible with all the features that you are trying to use? There's a great example, the RB753 GR3 block diagram, the hex router. So if you were trying to route at high speed between Ether 1 and Ether 3, they're both on the same 1 gigabit line to the CPU. It's not going to perform as well as you expected. Just by shifting the routing to, say, between Ether 1 and Ether 2, you would effectively double up the performance of your system. And put a little hint, a little idea for MikroTik there. Why don't you include this diagram in your device packaging? Let people actually understand what's going on there. Lack of understanding. One of my favorite quotes, just because you can do something does not mean that you should. You like that? Again, ties into the rest of the presentation. It's like, yes, so sure, you can take a router board 750 and it can run MPLS and it can run BGP and it can run OSPF and VPLS and it can do that all at the same time. Okay? But it's not going to do it very well, is it? Yeah, it's going to be terrible in that application. And again, that's your decision. If you want to take a low-spec router and use it for every single advanced application, the performance is going to be terrible, and that's not going to be to everyone's surprise except perhaps your own, because perhaps you weren't expecting that. So when your performance does not match your expectation, chances are you're using the wrong device or the device hasn't been configured in the correct way. And there are many, many other examples of this. Bandwidth test versus traffic generator versus the new speed test. Understand how those work and what they're being used for. If you use the old bandwidth test, the bandwidth test itself is going to generate a lot of CPU traffic. So don't try to run a bandwidth test on the same device that you're actually trying to test for throughput, because the CPU is going to spend 80% of its time running the bandwidth test, the other 20% of its time trying to run the network card, and almost no time on actually routing traffic through that device. So your performance is going to be poor. and you're going to wonder why, and that's probably going to be the reason. Other examples, using a multi-core device, which is great, but running all of your queues in the root level of your simple queue structure. The MikroTik system is optimized to use multiple CPUs in a queue tree type system. So if you have a system of multiple parent and child queues, it's going to allow the system to balance that out across multiple CPU cores at the same time, and in that way, again, you're going to get very much improved performance. And so on, many, many examples of that. I could carry on giving examples of bad client configuration until this afternoon sometime, but probably sure you've heard enough of me talking by now. So just to summarize finally, understand what your hardware was built to do, apply your software configuration in a smart way, match your application with the correct configuration and your correct router specification, and hopefully at the end of that you won't hate MikroTik any longer. Okay, thank you very much.